Hey guys, Skylar here. I'm at Gems to Junk Auto Sales with Jill. Jill's in the market for a set of wheels, her first car. Now, she sees herself in a sports car, but I think one of these beauties is a little more in line with her budget. In a few years, Jill hopes to trade in her first car for her dream car. When making her selection, she'll have to keep resale value in mind and understand how cars depreciate. What will help is a clear understanding of exponential decay. So while Jill goes and kicks a few tires, let's take a drive through decay and get another problem solved. Maybe you need to keep looking. To begin, you have to understand that the value of Jill's car will decrease over time. I'll use this car to explain. Right now, the car is worth $10,000. $10,000 is 100% of the car's value. Assume the value decreases or decays at a rate of 12% or 12 hundredths per year. This is the decay rate. Over the next year, the car's value will depreciate or decay by 12% of $10,000, which is $1,200. Ouch! Let's find its value after 1 year. We'll take 100% of the original value and subtract 12% of the original value. So, $10,000 times 100%, or 1, minus $10,000 times 12%, or 12 hundredths, is equal to 10,000 times 1 minus 12 hundredths, or 10,000 times 88 hundredths, which equals $8,800, the value 1 year from now. 12% or 12 hundredths is our decay rate, but the decay factor is 1 minus 12 hundredths, which equals 88 hundredths, or 88%. The decay factor is the amount of value the car maintains from year to year. It's always between 0 and 1. Now, let's create a table and graph to estimate the value of the car 2 years from now. To find the value at the end of the second year, we take the estimated value of the car after the first year and multiply it by the decay factor of 88 hundredths, which is 7,744. If we continue the process of multiplying our new value by the decay factor, we predict it will be approximately $6,815 by the end of the third year. I'm going to hit the brakes for a sec. Look at this. During the first year, the car value is predicted to depreciate by $1,200. But during the second year, the car's value is predicted to depreciate by less than $1,200. The depreciation is not the same from year to year. Let's say Jill wants to find out what the value of the car will be in 10 years. She could continue to multiply by 88 hundredths for each of the 10 years. But as you may have guessed, there is another way. Let's go back to the table. We started with $10,000 and multiplied by our decay factor of 88 hundredths. Then, to find the estimated value of the car at the end of the second year, we multiplied our value at the end of year 1 by 88 hundredths. Remember, 10,000 times 88 hundredths is equal to 8,800. So to help us find a pattern, we're going to replace 8,800 with 10,000 times 88 hundredths. For the third year, we multiply the second year's value by 88 hundredths. Let's write 7,744 as 10,000 times 88 hundredths times 88 hundredths. Look at the calculations through the third year. The pattern's right there. We repeatedly multiplied by the decay factor. We can go a step further by using exponents. Exponents help us calculate the predicted value for any year, which is represented by n. We simply take 10,000 times 88 hundredths raised to the nth power. If we want to predict what the car's value would be in 10 years, we take $10,000 times 88 hundredths raised to the 10th power, which is approximately $2,785. So if Jill bought this car today for $10,000, she could expect to resell or trade it in for about $2,785 10 years from now. Now, we're talking cars today. But we can calculate decay for any situation if we can identify just two important values. The value of the dependent variable when n equals 0, which is a, and the decay factor, which is 1 minus r. Why don't we try identifying these two special values in our equation? Remember, a is the value of the dependent variable when n equals 0. Notice in our equation, this value, a, is 10,000. The second important value is the decay factor. In our example, the decay factor is 88 hundredths. This is 1 minus the decay rate, r. Let's generalize our result. Instead of using v for value and n for number of years, we can replace these variables with y and x. So any exponential decay equation can be represented by y equals a times the quantity 1 minus r to the x power. There, you're ready to roll. Here's something to remember. The greatest decay always occurs right away, then lessens over time. In the first year, the car's value will decrease by a whopping $1,200. But in the 10th year, we're predicting it will only decrease by about $380. Turns out, Jill is a pretty shrewd negotiator. As she closes the deal, keep in mind there are always a lot of factors influencing actual decay. You should be ready to apply your understanding of exponential decay in similar situations. Problem solved!